Welcome dear students, welcome to our today's online class. Today we are going to start our new chapter which is based on simple linear equations. Simple linear equations, okay? Now this linear equation means it is an equation related to a straight line, okay? That is why it is called a linear equation, which is from chapter number 12. And after this video, after this session, you will be able to solve any given linear equations. So let us start our today's class. Before we start our today's class, let us first understand what do we mean by equation. An equation is a statement which states that the two expressions are equal. Okay, so whenever we see an equation, we have to understand that the two statements are equal to each other. For example, if 3x plus 2 and 11 are equal, so these are two expressions. 3x plus 2 is one expression and 11 is another expression. But if they are equal, then how can we represent this in the form of equation? We can write 3x plus 2. 3x plus 2 equals to 11. And when we write in this way, this forms an equation. Is that clear? Let us take another example. If 3x plus 2 and x minus 6 are equal, so here we have two expressions. And if they are equal, how can we represent them in equation form? Then 3x plus 2 equals to x minus 6 forms an equation. So equation tells us that any two expressions are equal. To solve an equation means to find the value of variable used in it. For example, here in these two examples, x is the variable used. Over here also x are used as variables. So to solve an equation means to find the value of this variable from the equation. Is that clear, students? For example, let's take example number 1. 3x plus 2 equals to 11. So this is an equation. Now here the variable used is x. So we need to find the value of x, and that is how we solve the equation. So how can we do that? We will try to keep the variable on left hand side and take all the constant terms to the right hand side or to the other side of equality sign. Okay, so 3x will be equal to 11. This plus 2 will become minus 2. When we solve this, we get 3x equals to 9. Okay, now this means x is equal to, this 3 will come to the denominator. So x is equal to 9 upon 3. And when we divide 9 by 3, we get x equals to 3. So x is the value of, 3 is the value of x in the given equation. And this, the value of x, is also called root of the equation. 3x plus 2 equals to 11. So we are supposed to find the root of x or the value of x from the given equation. Is that clear? And that is what is called solving the equation. Let's take another example. 3x plus 2 equals to x minus 6. So we'll keep the variables on one side and all the constant terms to the other side of equal to sign. So 3x, this plus x, when it comes to this side, it becomes minus x, equals to minus 6 will remain as it is. This plus 2 will become minus 2. Or when we solve this, we get 2x equals to minus 6 minus 2. They both have same sign, so they will add up, but they will have minus sign. So minus 8. And when we solve this, we get x is equal to minus 8 upon 2. So 8 goes how many times by 2? 4 times, but with negative sign. So therefore x is equal to minus 4. So this is how we solve any given linear equation. An equation remains unchanged if we follow certain operations, or we do certain operations. Let's see what are those operations. So the value of equation remains unchanged if we add the same number to each side of the equation. For example, if 2a equals to 4 is a given linear equation, then if we add 2, so we have to add 2 on the both side of the equation. So 2a plus 2 will be equal to 4 plus 2. Okay, we are adding 2 on the same two sides of the equation. When we solve this, we get 2a equals to 4 plus 2 is 6, and this plus 2 will become minus 2. So this will give us 2a equals to 4. So we came back to the same equation. This means when we add the same number on both sides of the equation, we get the same equation. That means the equation does not change. Second operation, if we subtract the same number from each side of the equation. For example, let's take the same equation, 2a equals to 4. Now if we subtract 2 from both sides of the equation, so 2a minus 2 equals to 4 minus 2. So this will give us 2a equals to 4 minus 2 is 2, and this minus 2 will become plus 2. So this will be finally 2a equals to 4, which is same as the equation which we started with. Okay, another operation is if we multiply each side of the equation by the same number. Please remember, whatever operation we are doing on one side, we have to do the same operation on the other side. Okay, so let's see with multiplication. 2a equals to 4. We'll take the same equation. So 2a multiplied by 2 is equal to 4 multiplied by 2. So we are multiplying both sides by 2. So this will give us 2a into 2 is 4a equals to 4 into 2 is 8. Or this will be 2a equals to 4, because this can be now divided by 2. 2 2s are 4, 2 4s are 8. So which means the same as the earlier equation. And finally, the equation remains unchanged if we divide each side of the equation by the same non-zero number. Please remember, we cannot divide the equation by 0, because if we divide any number by 0, then we get undefined number. Therefore, we have to divide each equation by non-zero number other than 0. For example, 2a equals to 4. So 2a divided by 2 equals to 4 divided by 2. Here we are dividing by 2 on both sides. So this will give us this 2 and 2 gets cancelled. So we will get again 2a equals to 4. So this proves that an equation remains unchanged if we add, subtract, multiply or divide both sides of the equation by the same number. Is that clear, students? So with this knowledge, let us start our exercise 12a. Solve the following equation. We'll start with question number 1. X plus 5 equals to 10. So here we are supposed to find the value of x. So x plus 5 equals to 10. So we'll keep x on one side, or x equals to, we'll take 5 to the other side, 10 minus 5. And when we solve this, we get x equals to 5. So this is the required value of x. So this is the answer. Is that clear, students? Let's take another question. Question number 7. 14 equals to 7m. Now this variable is on the right side and the constant term is on the left hand side. It doesn't mean that our variable has to be on the left hand side. We can keep our variable on the right hand side also, but for convenient, let's take it to the left hand side. Okay, so 14 is equal to 7m. This can be written as 7m equals to 14. This means the same thing. Okay, now we need to find the value of m. So m is equal to 14 divided by 7, and when we divide 14 by 7, we get m equals to 2. 7 2s are 14. So this is the value of m. Okay, let's take another question. Question number 17. A upon 15 minus 2 equals to 0. Okay, so here we have 0 on the right hand side of equal to sign. So we'll keep this variable. A divided by 15 is variable term. So we'll keep this on left hand side and we'll take -2 to the other side. Okay, so let's do this. So a by 15 equals to -2 will become +2. Now these are in multiplication and division form. So how do we do that? A will be 15 will cross multiply, will multiply 2, and 15 2s is 30. Okay, so therefore A is equal to 30. So this is the required value of A, which we also call root of the equation. A upon 15 minus 2 equals to 0. Let's take the last one. Question number 22. P plus 0.02 equals to 0.08. Okay, so P plus 0.02 equals to 0.08. So we solve this by taking the constant term to the other side. So P is equal to 0.08 minus 0.02. Now 0.08 minus 0.02 will give us 0.06. Therefore P is 0.06. So this is the answer or the value of P according to the given linear equation. So this way we have to solve linear equation and find the value of root of the particular linear equation. Is that clear, dear students? So this much for today. Based on today's class, there is an assignment given to you. Please do it and send it to me. Until we meet next time, stay safe and do all things well.